Yeah, hello viewers. Greetings to you and welcome to this live broadcast. Here I'm going to show you how to size your solar panels. If you have been following my videos, there's a system we have been designing and we carried out a load audit or load analysis where we prepared the load analysis table. And from the load analysis table, we have the total wattage of the loads and also the total daily energy consumption of the load. And we said the total power of the loads is 638 watts, and the energy consumption, the energy demand for the home is 2,542 watts hour. So from this daily energy consumption, we have designed the battery bank. You can watch my previous videos, those of you who have not watched, to see how I designed. We use this value to design the size of the battery that will contain this energy demand. Now for today, we are looking at the solar panels, how to size the solar panels. Now, when the appliances in the house consume this energy, the next day when there is sun, you need enough solar panels that will be able to generate this energy and replenish it in the battery. So it is very important as an installer, a solar installer, to properly size a solar system. Now, some people are complaining, oh, why the long calculations? Why do you carry out calculations? There's no need for calculations. You can just look at the system and know what to do. It's a very big lie. Now, the solar system is not like the generator that is already coupled. You just need to buy fuel. You know the quantity of fuel from your tank. You just buy the fuel and fill the tank, switch on the generator and there's light. No, the solar system is made up of different components. And all these components, you need to know how to combine them so that they'll be able to generate enough the energy that you need every day. Because if the solar panels cannot generate this energy, it means you'll be having issues with your clients. If the solar panels generate this energy and the energy cannot be stored in your battery, you will also be having issues with your client. If you cannot size an inverter that will be able to power these loads, you also have issues because the system will not function efficiently. So that is why you need to know the process. Always learn the process of anything. In any business, in any handwork, in any field, there is always a process. So always learn the process. Don't look for shortcuts. Don't look for a way you bypass, so that you achieve that thing in an easier way. Yes, there are ways that you can use, like if you want to design a system, you can use a software. There are softwares that will ease the operation. But the software also rely on all these theoretical principles. That is the theoretical aspect of it, makes use of the formula and the step-by-step process on how to do this thing so that you'll be able to achieve it. So don't follow or mind those who are always saying there's no need. I can go and learn this thing from anybody. I can learn it. I am already an electrician. Yes, you're an electrician. But if you don't know how to combine all these things, it will be difficult for you. Get it for me. Please, Duster. So you should just calm down so that you learn the process. And when you learn the process, it will be profitable to you because you are going to enjoy it. Anytime somebody calls you, a client, that my system is having a problem, if you have this theoretical background, this theoretical knowledge, it won't be difficult for you to solve that issue because you can trace where the problem is coming from. But when you don't know this background, you don't have this background, it will be difficult for you to, solve that problem. So here we have already sized the battery bank. I'm going to show you how to size the solar panels. So our energy is equal to 2,452 watts hour. Remember, this is energy. It is either in watt hour or in kilowatt hour. Then power is in watts. Why this one is in watt hour is because watts multiplied by hours. That's the power rating multiplied by the runtime hours of the load. So that is why we are having watt hour. So if you have your calculator, let's just go straight without wasting much time. Now, if you want to size solar panels, there are steps you need to take and there are things you need to consider. I think in my first video where I showed you how to, calculate the number of panels that are needed to charge a 200 amps battery, I made mention of something. We call it performance ratio. Performance ratio. This is not the efficiency of the solar panel. The efficiency of the solar panels ranges from about 16%, that's the solar cells, from 16% to 23%, depending on the quality of the panels. Some of them, like some are claiming, you can have up to 30-something percent cell efficiency. Now, the efficiency of that panel is the ability of the cells to convert the sun's energy into electricity. Once the sun hits on the panel, on the cells, the ability or the ability of that cell to convert the sun's energy into electricity is what we call the cell efficiency. So if they say the cell efficiency of a panel is 60%, it means the amount of sunshine it receives, it will be able to convert 16% of that sunshine amount to electricity. Now, for performance ratio, if you look at the back of your panel, there are parameters that are given in that panel. Please excuse me. There are parameters that are given in that panel. We have the open circuit voltage, which is the VOC. We have the short circuit current. Then we have the maximum power voltage. We call it VMPP, maximum power voltage. Then we have the maximum power current, IMPP. Then we have the Pmax, that's the maximum power of the panels. Now, for example, if the maximum power of this panel, if the maximum power of the panel is, let's assume, is 200 watts, and the open circuit voltage is 36 volts, this is assumption, and the short circuit current is 8.0 amps, then the maximum power voltage is maybe 32 volts, and the maximum power current is maybe 7.8 amps. Now, the manufacturer, what is called, there's what is written on the back of that panel called STC. It is standard test condition. Standard test conditions. It means these parameters were gotten from the laboratory after manufacturing the panel with an irradiance of 1,000 watts per square meter and a cell temperature of 25 degrees centigrade and atmospheric of about, I think, 1.5 atmospheric. Now, these conditions, it is under these conditions that these things were measured inside the laboratory. When the panels are exposed to high beam of light in the laboratory, that is when the irradiance is 1,000 watts per square meter, the temperature is 25 degrees, and the atmospheric is 1.5. When you look at the back of that panel, you'll see all these parameters. But when you bring out this panel to the real world situation, to real life situation. Maybe this panel is manufactured in US and you bring it to Nigeria. The weather condition, the climatic conditions in Nigeria is different from that of America. So these parameters you're seeing, these irradiance, it's difficult for you to get this 1,000 watts per square meter, even in the north. If at all you have this 1,000 watts per square meter, it won't last. At times, it may last for 5 minutes or 10 minutes. So these parameters, when you bring them to the real life situation, these parameters are not constant. But inside the laboratory, they are constant. And the manufacturer is telling you that under standard test conditions, that is when the panel can produce its maximum at 200 watts. And all these parameters are kept constant. But when you bring it out, these things, you are not certain of these things, because we have weather conditions that we as humans cannot control. They are controlled by God. So that is why when you get your panel and when you are sizing your solar panel, you need to take into consideration the PRO, which is called the performance ratio of that panel. It means that since these panels cannot produce up to their rated capacity of 200 watts, therefore, it means there's a percentage we should take that these panels can produce only 65% of their rated capacity. So you can check 65 of 200 watts. What you get is what this 200 watt panel in the real life situation will be able to produce. So if you just take these 200 watts and you have two of them and you say it is complete 400 watts, this panel will be able to generate complete 400 watts. You are deceiving yourself. There's no way this panel can generate 200 watts from morning till from sunset till when from sunrise to sunset. It is impossible because you cannot control the weather. In fact, the panels produce at most from 12 p.m. to around maybe 2 p.m. That is when panels, that's the peak of their production. If you carry out the experiment outside with your panels, you see that their production capacity increases from 12 p.m. to 2 p.m. So because of these conditions, that is why we introduce the performance ratio. So we are going to make use of this 65. But now, technology is increasing, it's improving every day. There are powerful panels that you can make their performance ratio up to 70% or even 80%. But it is difficult for a panel to give you complete power production as it is written the nameplate. If you have a 300 watts panel, that 300 watts panel cannot give you complete 300 watts when you expose it to the sun. It's difficult. So the first thing we are going to consider is the performance ratio of the solar panels. So I've talked about the performance ratio. Another one also, I discussed that one when I was sizing the battery bank, that you need to also consider the inverter's efficiency. And we made use of 90%, which is the same as 0.9. So we are going to use it also. Then the next thing is the peak sun hours, PSH. The peak sun hours. Peak sun hours is the availability of sunshine in a particular place, given a time duration. Like, for example, in Nigeria, if you are in northern or southern Nigeria, if the sun rises in the morning, how many hours does it last on the average? We are talking of the average now. And when we are talking of the average, is from January to December. And you get this data from your what's it called, meteorological agency, January to December. So we have peak sun hours. How many on the average? How many hours will the sun last? Does the sun last in your location? Because the intensity of sunshine is not steady. It is not constant. It is not a factor that we can control. The sun may rise and just stay for 2 hours and there will be no sun again. During rainy days or cloudy days, throughout the whole day, there may be no sun. So we are taking all these factors into consideration, because when you size a solar panel and you think the panels, if you your panel capacity is 2000 watts peak, and you think these panels will generate 2000 watt peak constantly every day from morning till night, that is from maybe 8 a.m. to maybe 4 p.m. or 5 p.m. This panel will be generating constantly 2000 watt peak. It is impossible. It is unrealistic. It is not something you can achieve. So you need to take these things into consideration, so that after designing the system and you install it, during worst case scenarios, when the weather is not bright, there is no enough sunshine, because you have factored in all these things, the panels will still be able to generate an amount of energy that will serve your client's energy needs. So peak sun hours is the amount or the availability of sunshine in a particular location, per given time. So for this our calculation, because let's use 5 hours, we will use 5 hours as our peak sun hours. Then after designing, you'll now decide whether you're connecting the panels in series, or you're connecting them in parallel, or you are doing a series parallel connection. So after you have the number of panels, you now decide on what to do. So to design the number of panels that will generate this energy and store in the battery, step 1, we will divide this value. If you have your calculators, let's do it together. We will divide this value by the inverter's efficiency, which is 0.9. So step 1, we say 2,452 watts hour. This is 2,542 watts hour, sorry. So I said divide by the inverter's efficiency, which is 0.9. So this will be 0.9. What will it give us? 2,452 divide 0.9. 2,000, sorry, 2,000, I'm making a mistake. It's not 4. 2,542. Please correct it. 2,542. What am I using for? 542 divide 0.9. So let's check the value again. 2,542 divide 0.9. This will give us 2,824.4. Then we have step 2. We will divide this value by the performance ratio of the panel. This one by the performance ratio of the panel, and our performance ratio is 0.65, which is 65%. That the panels will only be able to generate a usable amount of energy. The percentage they will be able to generate is 65% of their rated capacity. So we'll divide this 2,824.4 by 0.65. This will give us 2,824.4 divide 0.65. This will give us 4,345.2. So this is what we have. Then we have step 3. You divide this by the peak sun hours, and I said we are going to use 5 as our peak sun hours. So this will be 4,345.2 divided by 5. 4,345.2. 4,345.2 divided by 5 will give us 869 .04, which is approximately 800 and can use 869. So this is what we have, 869. So step 4, we are going to divide this value by the rated capacity of the panel you want to use. We have 100 watts panel, 150 watt, 180, 200 watt, 250, 300, even up to like Trina Solar, up to 600 watts solar panel. So you choose the wattage you want to use, and before you choose, you should make sure that that wattage is in the market. You can easily get it, you can easily source it, so that you'll be able to deliver the job on time. So we have 869. What size of panel are we going to use? What size of panel are we going to use? We are going to choose the size of panel. So let's assume we are using a 320 watts panel. We want to use a 320 watts panel. Remember that the battery bank we designed is a 24 volts battery bank. 24 volts battery bank. So if we choose 320 watts panel, it will be 869 divided by 320. So 869 divide 320. This will give us 2.7 panels. So you can approximate it to 3 panels. So we need 3 solar panels of 320 watts peak. So if we get this 320 watt panel, we now look at the nameplates, the specification sheets at the back of the panel. That is where we will see the VOC, the open circuit voltage, the short circuit current, the VMPP, the IMPP, maximum power voltage and maximum power current. So these ones now, if we get them from the panel, they will guide us in sizing the charge controller. So this is how to size the solar panels that are needed to generate the energy that will be stored in your battery bank. The energy that will be stored in your battery bank. So from here, after getting these values, we will now know if we are going to connect these 3 panels in series or in parallel. But from here, if we have these 3 panels, if you are using an MPPT charge controller, you can connect these 3 panels in series, because most charge controllers, but you need to look at the maximum PV open circuit voltage. Most of them is 150 volts. So even if we have a 320 watt panel which VOC is maybe 45 volts, is to multiply this 45 by 3, which will give you around 130 something volts. So you connect them in series if it is an MPPT charge controller. But for a PWM, you can connect them in parallel, and it will still serve the same purpose. So this is how to size your solar panels. If you have any question, you can just drop it at the comment section and I will respond. I like doing it live so that you'll be able to understand, you follow the steps, you follow the process, and we can interact in a real time. So thank you very much for joining my live broadcast. Drop your comments or your questions, and I will be available to attend to them. Thank you very, very much for joining. Stay blessed.